In this video, we're going to take a look at the practice exam for Chapter 7 of Intermediate Algebra. All right, so the first question on the exam is to solve this equation. Give the exact solutions and approximate solutions to three decimal places where appropriate. That phrase "where appropriate" can be misleading because I think they use that on a few of these problems. If the solution is imaginary, it's not appropriate to do a decimal solution. Or if it comes out as a nice answer. So if you get like a whole number or a fraction, like a nice fraction, like 2/3 or something, you could just leave it as 2/3. This is really referring to if you get a radical in your answer and it's not an imaginary number, then plug it into your calculator to get a decimal approximation. So we're going to solve this. This is a quadratic equation, but this one is one of the nicer, well, it looks nicer, at least initially. What's nice about it is there's just one x in the whole equation. And so if that's the case, you can just get x by itself. So even if it's quadratic, if there's only one x in the whole equation that you're looking at, move everything to the other side to get x by itself. So we'll start here by adding 5 to both sides. We get 2x squared is equal to 5. Then we divide by 2, and we'll get x squared is equal to 5/2. And this is a new method, a new technique that you'll learn in Chapter 7 to get x by itself when it's being raised to the second power or any power, really. You'll use a radical, right? So to cancel out this power of 2, that's what square roots are for. Square roots cancel out powers of 2. If I do that to the left-hand side, do the same thing to the right-hand side, just like everything else we did here. And several things are going to happen because of this. So while this problem initially looks like a pretty straightforward problem, there's several things we're going to have to do. So it looks like initially we're going to get x equals the square root of 5/2. And a lot of students might stop there and say, okay, I solved it for x, but you're missing two things here, I guess. I was going to say several things, but that's maybe an exaggeration. One thing you need to remember to do, and nothing is going to remind you of this, you just have to make sure you remember, if you take the square root of both sides, you need to put a plus or minus on the right-hand side of that result. Right? So we took the square root of both sides, put a plus or minus right there. The other thing we're going to have to do with this result is we'll need to simplify it, and this goes back to Chapter 6 on radicals. You can apply the square root to the top and bottom of this fraction. And something we learned in Chapter 6 is we don't like having radicals in the denominator. So we need to simplify this by removing that square root from the denominator, and this is called rationalizing the denominator. And it's accomplished with square roots. Something that always works, it may not always be the best way to do it, but what always works is multiplying the square root by itself. So I'll just multiply the square root of 2 times another square root of 2, and what I end up with is 2. Square root of 2 times the square root of 2 is the square root of 4, but the square root of 4 becomes 2, and so the radical goes away. If I do the same thing to the bottom, I got to do the same thing to the top. And so we'll get square root of 10 on top, right? 5 times 2 is going to give me 10. And so this would be the solution set to the equation. And so you can just, on paper, leave it right here. But if this was on Math Excel, you would type this into the box that's right here, using the plus or minus key for this notation, and then typing that in. And this one, it is appropriate to come up with a decimal solution to three decimal places. So you want the exact answer here, but then here they want the approximate answer to three decimal places. So that means plug it into your calculator and get a solution from that. All right, so excuse me. I'm going to take the square root. This calculator works a little bit backwards. I'll have to type in 10 for, I think that's how it's going to work here. Except I don't even see a radical button on this calculator. Maybe I'm just not looking right, but I feel like I've looked at every button and nothing is showing me a radical symbol. So I think what I'm going to do, something else we learned in Chapter 6, is that a square root really is just a 1/2 power. So I'm going to take 10 to the power of 1/2, or 0.5 if you want to use a decimal. And that's the same thing as the square root of 10. Sorry, I have to do it that way. So we get that, and then we're going to divide that by 2. And so you get this result. We want to go 3 decimal places, so that means we want to round this value, and we determine which way to round it based on this value. So it's a 1, which means we round it down, which means this will just stay a 1. So we get 1.581 is what this equals approximately, 1.581, and we have both positive and negative. 1.581 is our solution. All right. Let's take a look at this next example. Give exact and approximate solutions to 3 decimal places. This one doesn't say where appropriate, but it kind of does down here when it actually asks for the information. And this is going to be one where it's actually not appropriate to do an approximate solution. So there are no approximate solutions since there are no radicals in the solution. That's going to be the option here. And you'll see that in just a second. So this is a different arrangement of the equation than what we just did, but it still fits the criteria of solving because there's just one x in the equation, right? It's arranged differently, but this is a quadratic equation, but there's only one x in the equation, which means you should still be able to get the solution by just getting x by itself. So it's going to look different than question number 1, but it's the same rationale for how we're going to handle it. Right? Let's just get x by itself, move everything else to the other side. Now, to move everything else to the other side, we will first have to deal with this power of 2. So it's the big difference in this problem is you have to get rid of the square first. That was the last thing we did in question number 1, but it will be the first thing we have to do in question number 2. So to get x by itself, I got to cancel out that power of 2 first. To do that, I will apply a square root. So I'm going to do that right away. Make sure you do that to both sides. The square root cancels out the power of 2. So I'll just have x minus 3 left equals the square root of negative 25. Just like we learned in the previous example, when you take the square root of both sides, you have to apply a plus or minus. You have to do it now. You can't wait till the end. You got to apply it right away. And then we will get x by itself by adding 3 to both sides. Now, usually if a plus or minus is involved, and you're going to bring something else over, you want to place it in front of the plus or minus. That's just the standard way of writing it, but you don't have to. So mathematically speaking, it doesn't really matter where this plus 3 goes. The place that I've been trained to put it, what looks right to me, is to have it in front of the plus or minus. But if you were to write it like this, keeping the plus or minus in front of the radical and putting the plus 3 after, that's okay too. I mean, there's certainly, mathematically speaking, there's no difference between these two, but this just looks more correct to me anyways. Now we're not quite done because we want to simplify the square root. And something else we learned in chapter 6, I keep bringing up chapter 6, but it's really relevant for these problems. When you take the square root of a negative number, that makes the number imaginary. So we'll still have plus or minus. Let's try that minus sign again. And we'll have a negative, not negative. This negative sign becomes imaginary outside the square root. And then once the negative sign's out of the picture, square root of 25, you should just automatically know what that is. It is 5, right? So this is going to become 5, I times 5, which we just write as 5i. And so that would be the final result here. So my two solutions are, there's really two answers here, 3 plus 5i and 3 minus 5i, but you can just leave it as plus or minus. That's really acceptable here. And this cannot be approximated because there's no radicals. And so that's the end of that problem. Okay, let's take a look at number 3. Solve the following equation by completing the square. And so this particular problem is a quadratic equation, but we have two x's in the equation, which means we cannot use the same technique as the first two problems. No amount of adding, subtracting, multiplying, dividing, square roots will get x by itself in this setup. We have to use a different method, and this different method produces, so completing the square is a method of rewriting the equation so that there is only one x in the equation. And then once you only have one x, then you can do what we did on the previous two problems. You can get x by itself. All right, so this is a precursor to using the quadratic formula, which we'll be getting to here in just a minute, which you could use here. And again, my students, completing the square, it's, this is intermediate algebra. You're going to be taking college algebra next. There is one problem that I can think of off the top of my head right now where you do need to know this technique, and it has to do with circles, and that's something that we cover in college algebra. So it is something that's worth your time learning now. But on this test, it's the end of the semester. I'm more than thrilled if you're able to solve this using the quadratic formula. So if you just want to go that route, that's fine. You cannot just get x by itself the way this is set up, but you could use the quadratic formula, or you can use this technique that they're actually referring to in the directions, completing the square. And this problem is really set up to be done that way. They have the x squared and the x already by itself on the left-hand side. What I'm going to do is rewrite the equation with a little bit of a space there, because the whole method of completing the square is about finding the special magic number that you need here for this to factor as a perfect square. Because when it factors as a perfect square, it's going to factor as x plus or minus some number to the second power. Right? If you get the same factor twice, you can write it as that factor to the second power. And if you can write it like this, there's just one x in your equation now. And then you can solve for x from there. Right? But in order for all that to happen, we need to figure out what number belongs here so that it will factor in this way. And so that's why the 10 is over here on the right-hand side, because the 10 isn't what we need here. We need to figure out a different number for this to work out the right way. And the process for finding that special number is to take the value for b. Well, let me back up a little bit there. And this is where completing the square, that technique can become fairly challenging. There needs to be a 1 in front of the x squared, which is already the case for this problem, already the case for number 4 as well. If there's not a 1 here, you have to factor that number out first before you can, begin this process. And factoring it out can sometimes create fractions. That's where things kind of go sideways. But for this one, we're in good shape. It's already a 1. So what we do is take b, which is negative 18, right, whatever that value for b is. We divide that by 2, and so that gives me negative 9. That's b divided by 2. And then we square that. Raise it to the second power. So pretty simple operations. Take the value for b, divide it by 2, and then raise it to the second power. Whatever number you get from that process, that is the special number that needs to go here for this to factor in this particular way. So I'm going to add an 81 to this so that it's set up to factor the way I need it to factor. If I add 81 to the left-hand side, I have to add 81 to the right-hand side as well. I have to balance that out. So the left-hand side factors. Now, because this is a 1, pretty easy thing to factor. And because these aren't fractions, right? We just have to find two numbers that multiply to 81, add to negative 18. That's going to be negative 9 and negative 9. So this will be x minus 9 times x minus 9, which gives me the same factor twice, which is the whole point of this exercise. This process is designed to create an expression that will factor as the same factor twice, so that you can write it as, in this case, x minus 9 to the second power. All right. And the right-hand side, I'm just going to skip down here, 10 plus 81 is going to give me 91. So now I've reformatted my equation to make it look like the problem we just did up here. So it didn't start off looking this way, but now that I've completed the square, I've gone from this to this. And now it can be solved the same way we did number 2. All right, which is to get x by itself, we will take the square root of both sides of the equation. So I'm going to apply square root to the left-hand side, square root to the right-hand side. That square root cancels out that power of 2. we end up with just x minus 9 equals the square root of 91. Because we took the square root of both sides, we have to apply a plus or minus to that. And then we're going to add 9 to get x by itself. And so we get x equals 9 plus or minus the square root of 91. You might be thinking, oh gosh, 91, what a horrible number to have there. I don't think 91 is prime. I'm honestly not sure off the top of my head, but what I'm more sure about is there's no way to simplify that. So I think we're just stuck with square root of 91. So, some students will look at that and think, oh, that's a really tough number to have there. What am I going to do with that? But a lot of times, if there's nothing you can do with it, that's actually better because you're done sooner, right? If this was, negative 25 like it was up here, we'd have to simplify it. We'd have to get imaginary and take the square root of 25. If this was like square root of 8, we'd have to split up the 8 and we'd get some part of it outside the square root. But with 91, I don't think any of those avenues are possible. So I'm trying to think with 91, I do want to say there's factors to it, but something like 17, I don't know. It's just the factors of 91 are not going to simplify in such a way that we can reduce this radical. Reducing maybe isn't the right word there, but we're not going to be able to simplify this radical. There's no way to rewrite 91 for that to happen. Anyways, I'm belaboring the point. I should just go ahead and stop talking and put a box around that. So that is our exact solution. And thankfully they don't ask for approximate, but this is one that you could approximate. You could plug this into your calculator. You would get two different answers. You get 9 plus square root of 91 in your calculator as one decimal answer, and then 9 minus square root of 91 to get your other answer. All right. And so let's take a look at, I thought I was done, but I kind of tricked myself there because we have one more problem here that we just kind of invaded the space of that problem by accident. So let's scroll down a little bit more so we have some more room. So this one, they want us to solve by completing the square again. So let's go ahead and follow the directions. Again, you could use the quadratic formula. It depends on your teacher, all right? So if I'm your teacher, I'm okay if you use the quadratic formula, but other teachers may be specifically wanting you to complete the square, and so you need to do it by how the directions are prescribing. And in that case, you'll need to do it the way we're about to do it, all right? I'm going to set this up the same way number 3 was set up. So I want to focus on these two terms here and figure out how to make this factor as a perfect square, just like we did up here. The 20 is just going to get in my way, so I'm going to subtract the 20 to the right-hand side and get it out of the way. So I'll have x squared minus 8x, leave a space for the special magic number that I need there, and then we'll have negative 20 on the right-hand side. Again, you need a to equal 1 in order for this technique to work. It's already equal to 1, so that's a big help. So we'll start with b, which is negative 8. We want to divide that by 2, so negative 8 divided by, I'm writing the answer, negative 8 divided by 2 is negative 4. And then we want to square that. So we want to raise that, I kind of messed that up too. We want to raise that to the second power. So we're taking the b divided by 2 and squaring it. So I'm going to take negative 4 squared, which comes out positive 16. That's the special number that I need to see right here. So I'm going to add 16 to the left-hand side, so this will factor the way I need it to factor. To balance that out, I need to also add 16 to the right-hand side. So now we can factor this. Again, because there's no fractions here, we can factor it the usual way, which is two numbers that multiply to 16, add to negative 8. That's going to be negative 4 and negative 4. You better be getting the same factor here twice. If these are two different factors, you did it wrong, right? And then negative 20 plus 16 is going to be negative 4. Because it's the same factor twice, I can rewrite it as that factor to the second power. And now, because there's just one x in my equation, I can solve this for x. Take the square root of both sides. We'll get x minus 4 equals plus or minus the square root of negative 4. We will add the 4 to the other side. And so we'll get x is equal to 4 plus or minus the square root of negative 4, which is going to be 2i. So I'm going to speed things up a little bit here. The negative sign we talked about earlier becomes imaginary, and then the square root of 4 is going to give me 2. And then this would be our solution set. All right, let's take a look at the next page. All right, so for number 5, they're asking us to solve this for x. does not say to complete the square, so now we are being given permission to use the quadratic formula to solve this equation. The quadratic formula is used to solve equations of the form ax squared plus bx plus c equals 0. So it's important when you're using the quadratic formula that you have the equation equal to 0 first. Then you can identify a, b, and c. So in this case, a is equal to 1, b is equal to 18, c is equal to 4. And then you take those numbers and you plug them into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. And so we're going to plug in for b, we're going to plug in 18. So I'll get negative 18 plus or minus the square root of b squared will be 18 squared minus 4 times a, which is 1, times c, which is 4. The whole thing divided by 2 times a, which is 1. And what's amazing about the quadratic formula is that you just solve the equation just like that. Right? It does all the work for you. Really what the quadratic formula has done, what it's designed, like the way it was, discovered, is from completing the square. Taking this formula here and then completing the square with a, b, and c left in there instead of having specific numbers. So it's kind of challenging to complete the square with a, b's, and c's there, but that's what has been done. And that leads you to the quadratic formula. So when you use the quadratic formula, it's completing the square for you and it's solving for x for you. It's doing all the work. All you have to do is dump in the numbers after the fact. However, it's too good to be true because even though it instantly gives you the solution, it's a mess, right? You can't leave your answer looking like this. So even though it takes a lot of the work out of it, there's still going to be some work involved in simplifying your answer that you get. So we're going to get x equals negative 18 plus or minus the square root of 18. I probably should know this off the top of my head. 324. I think it's 324. All right, so 324 minus, so the way I kind of figure that out is I started with 20 squared, I know is 400. So I know it needs to be less than that. I know the last digit's going to be determined by 8 times 8, which is 64. So I know it's going to end with a 4. The 6 is going to carry over to the next calculation or whatever. And then I just tried to think of what numbers do I know that are squares that end in 4. That's how I got 324. I'm pretty sure that's right. Over 2 times 1, which is 2. Right? And then we'll take 324 minus 16. Now be careful not to say, oh, square root of 324 is 18. Square root of 16 is 4. You cannot split the square root up over these two numbers because you are subtracting them. You can apply the square root separately if you're multiplying or dividing, but not adding or subtracting. So what we need to do is actually subtract these numbers first. We get x equals negative 18 plus or minus the square root of 308 over 2. And then we need to use our skills from chapter 6 to simplify this radical by splitting it up. It looks like 4 would definitely work, but we might do better than that. So I'm going to try 4 at first, right? So this is going to be 4 times, 4 goes into 30 7 times. Right. Oh, that's a terrible 7. That's going to leave a 2. And then carry the 8 down. 4 goes into 28 7 times. So we're going to get 77. And the reason this is, how do I say, tentative, is because maybe the 77 could split up and I could get even more numbers that I could take the square root of. So I'm starting with 4 initially, but I'm willing to modify that if I find this number has more numbers that can be brought out of the square root. And so, but 77, I'm looking at that and I realize, well, the only way to get 77 is 7 times 11. Those numbers do not work well with square roots. And so nothing else is going to simplify out of this. So actually, this is the best way to split up 308 for this to simplify. There's no better number that we could get here. And so we apply the square root to each of these separately. We're going to get x equals negative 18 plus or minus the square root of 4 is 2. The square root of 77 just copies down. That whole thing's divided by 2. And then the last thing you want to try to do is reduce. And so you simplify the square root first, and then try to reduce your fraction. And so probably the easiest way to do that is just to divide the 2 into both of these, right? So you're going to get negative 18 divided by 2 is going to be negative 9, plus or minus. When 2 divides into this, the 2's cancel out, and you just have square root of 77 left. And there is our solution set for number 5. All right. I'm afraid I'm going to quickly run out of room here with this one. Actually, this is kind of funny. We already did this problem. Did we? No, I'm sorry. I don't think we did. I thought we did this problem on, sorry, I didn't mean to do that. Number 4 here. Oh, we did. Oh, man. So negative 8x plus 20. This is going to be, when we subtract the 8x over here, it's going to be the same problem again. So how crazy is that, right? I mean, because these problems are randomly generated to a point. I mean, they're generated in such a way that the answers will work out the way they're supposed to, but the numbers are supposed to vary and be somewhat random. And it's funny that we just got the same problem twice. So if this had been your actual test, hopefully you would have noticed that, and I would have been okay if you just said C number 4, because it's the same problem, right? So it's going to be the same solution. Of course, this one, they want us to solve by the quadratic formula. So let's go ahead and, even though it's going to be the same answer, let's go through that process so you can just see how it's different and how we still end up with the same answer either way, right? So the first step in using the quadratic formula is you have to get it equal to 0 first. So I have to subtract the 8x over here. And then I can identify a, b, and c once I've done that. A is equal to 1, b is negative 8, c is 20. I'm going to plug it into this formula. I won't bother rewriting the formula down here because it's still on the screen. I'm just going to go ahead and plug the numbers into that formula. So let's see if I can manage to squeeze that work right in here. So we'll have, now you got to be careful when b is negative. You have a negative sign in your formula, and then b is going to be negative 8. So you get a double negative there, right? Plus or minus the square root of b squared, that's going to be negative 8 squared, minus 4 times a, which is 1, times, I don't know why I put 2 parentheses there. Oh gosh, I hit the wrong button. I'm really making mistakes. All right, sorry, I was trying to undo. Now, the funny thing about this software is if I go to a different page and come back, I can't undo. Like, it just locks in whatever I wrote, so I'm stuck with that little typo there. And then times c, which is 20. And I also severely misjudged how much math I could fit into this space. All of that is divided by 2 times a, which is 1. All right, so it's plugging in these 3 numbers into this same formula, and this is what it initially looks like. When b is negative, there's a couple spots you need to be careful with. So here we got a double negative, which makes this positive 8. And then here, when I take negative 8 squared, that should always come out positive. So if you aren't careful with how you type that in your calculator, I get a lot of students that put negative 64 here, but it should be positive 64. Minus 4 times 1 times 20 is going to be 80. Over 2 times 1, which is going to be 2. We'll just continue over here. So we'll get 8 plus or minus the square root of negative 16 over 2. The square root of negative 16 will be 4i, right? The negative sign is what makes it imaginary. And then square root of 16 is how I get the 4. And then I reduce my fraction by taking the 2. Sorry, it kind of glitched on me there for some reason. Taking the 2, dividing it separately into each term. And so I'll get 8 divided by 2, which is 4, plus or minus 4i divided by 2. Well, the 4 reduces with the 2 and gives me a 2. And so we get 4 plus or minus 2i, which should be the result that we saw on this page here. All right. Can you arrive at it in a different way? The details are going to look a little bit different, but the solution is still the same. All right. Let's take a look at number 7. All right, so this one is a mess. The first step here is to simplify this mess, right? So it doesn't even look like it's quadratic yet, right? Because you have only x's to the first power. There's no x squared, right? That's the hallmark of a quadratic equation, is when you see x raised to the second power as your highest power of x. And we don't see that here yet, but we will pretty quickly, because we're going to have to to solve this, get rid of the parentheses, so we'll have to distribute. We'll get 4x squared minus 28x. So now we have x squared. We'll get minus 5x squared plus 30x equals negative 3. And maybe I've done kind of a bad job in picking these problems. I'm sure on the homework this didn't happen, but it's going to come out as a 1x squared. You know, it might be worthwhile having at least one where a is different than 1, just so you can see how that kind of changes. It changes the thing you're dividing by. It changes this part too, but it's what you're dividing by that you'll notice being most different. And reducing the fraction could be more challenging. So we get 4x squared minus 5x squared, which is negative x squared. I guess that's different than just a 1, but let's just see where this problem goes. So we combine the x squareds together. Negative 28x plus 30x gives me positive 2x. And then it equals negative 3. Now, what I was going to do is I don't like it when a is negative. I don't like it for factoring. I don't like it for solving using the quadratic formula. And so rather than add the 3 over here to make this side a 0, I'm going to go the other direction because it's that important to me. I find it's of that much value to have the a value be positive instead of negative. It's that helpful, even though this is going to be a little extra work. So I'm going to add the x squared over to the right-hand side. That way, this comes out as positive x squared. And because I'm getting 0 on the left-hand side, I got to get rid of the 2x, so I'll subtract the 2x over here as well. So I'll have 0 on the left-hand side. And then I'll put this in order, so we'll have x squared minus 2x minus 3. I kind of thought this might happen. So again, a is equal to 1. Which has happened every single time on every problem, unfortunately, on the test. I kind of feel like maybe I need to go back and revise my test, get a problem in here where a is not equal to 1. However, this one is even easier than that, not just because a is equal to 1, but because this problem we can solve without even using the quadratic formula or without completing the square. We can solve this one by just factoring. So always be on the lookout for this. I didn't mention it on my previous problems, but on every one, I did a quick mental check to see if it could be factored. This one you have to be careful about because it almost seems like it could factor, right? When you get it set up like this, you'd have to find two numbers that multiply to 20, add to negative 8. You might think 10 and 2, right? That kind of negative 10, positive 2, right? That gives you negative 8. And 10 and 2 give you 20 when you multiply them together. But if you do negative 10 and positive 2, that gives you negative 20. It doesn't give you positive 20, so the numbers don't quite work. But I did check. Before I used the quadratic formula, I checked to see, could I factor it instead? You do the same thing here. Can I factor this instead? Are there two numbers that multiply to negative 3 and add to negative 2? Well, yes, there are. Negative 3 and positive 1. And so this will factor as x minus 3 times x plus 1. Right, and again, we can use that shortcut of factoring because a is equal to 1 here, so that does contribute to making this problem even easier when a is equal to 1. But it can be factored. And so if you can solve it by factoring, that generally is going to be a better route to take than using the quadratic formula. After you factor it, you set each factor equal to 0. And then you solve for x. I'll add 3 to the other side. I get x is equal to positive 3. Subtract the 1 over, we get x is equal to negative 1. And we get our two solutions that way, rather than going through using the quadratic formula, which would give you the same answers, but with a lot more work. All right. So maybe here we can finally catch up on our space. For number 8, it's not asking us to solve the equation. So be careful not to just jump right into solving it. I might still give you a couple points if you're able to do that successfully, but you're going further with it than you need to. And now you could just, one way of answering this question is just to solve it and see what kind of answers you get. That misses the point of the problem, but I'd give that to you if you solved it and then you actually addressed the question here and you got it right. I wouldn't take any points off for that, but you would have done more work than you needed to. All right. This one just says determine the nature of the solutions. It doesn't say you have to actually solve the equation, just what do the solutions to this equation look like? Are they not positive? Are they real numbers? Are they imaginary numbers? Are there two or is there just one? All of those can be determined, all of that information can be determined by looking at the discriminant. The discriminant. Am I spelling that right? I feel like I'm not spelling it right. Let's back up here. Discriminant. Yeah, I guess that's right. Okay. Now the discriminant of the quadratic formula is the part of the formula beneath the square root. Right? So here's the quadratic formula. The discriminant is this expression inside the square root. The reason it's important, the reason it's given this distinction, is often, I've seen students where they write this as like a delta in their calculations. I guess delta for discriminant, right? So now, again, I'm not trying to, I hope this doesn't come off culturally insensitive or anything, but I just know like in American culture, I was never taught to use this triangle symbol in any of my math classes, I don't think, until you get to like calculus. But I wasn't taught to use it for the quadratic formula. But I've noticed that with students from other countries in my class, that they were taught to find this value as delta, as a triangle. And then they find that separately. So when they're doing the quadratic formula, they do this first. So they still have to know the formula, but they do this calculation separately. And then they remember the quadratic formula as negative b plus or minus the square root of delta over 2a or something like that. I might not even be doing it exactly right because it's not the way I was taught, but it looks something like this. But they refer to this as a delta. So it's this delta that you want to use for question number 8. And I think it's a great way to, in fact, I feel like those students who use this method seem to have a really good grasp of using the quadratic formula. They understand the parts of that formula, and they seem to, have an easier time with these problems. So to me, it seems like a better way to maybe approach learning this material. But again, different cultures do things differently. So this would be your delta. It's b squared minus 4ac. And this expression is what determines the nature of the solutions that you're going to get, because it's whatever happens in the square root that determines if your answers are imaginary or not. Right? So here we get 324 minus 16, which is 308. So the discriminant here, the delta, is 308. It's positive, so we got real solutions. These weren't imaginary, these are real solutions. And there's two of them because we have a plus or minus here. Whereas in this case, the delta is 64 minus 80, which is negative 16. And because it was negative, it produced an imaginary solution. So we got two imaginary solutions here. But whether it turns out imaginary or real depends on what's happening inside the square root. So that's all we're looking at here is, for this equation, what would be occurring inside the square root? Is it going to be a positive number, which means we get real solutions? Or is it going to be a negative number, which means we would get imaginary solutions? What I find interesting about this is that whether it turns out to be real or imaginary is affected by all three numbers. It's not just A, it's not just B, it's not just C. All three of them play a role in whether the solutions work out to be real or imaginary. Right? So we have A is equal to 1, B is equal to negative 2, C is equal to 5. So we'll plug those numbers in. We have negative 2 for B, minus 4 times A, which is 1, times C, which is 5. So negative 4 squared is 4, minus 4 times 1 times 5 is 20, 4 minus 20 is negative 16. Now, if you're one of my students and you do this, if you say x is equal to negative 16, I get a lot of students that do that, I'm going to take off points for that. Even though you're coming up with the right result here, it's not x. If you put x equals negative 16, it makes me believe that you think the solution to the equation is x equals negative 16. But this is not solution to the equation. This is just the number that we would get inside the square root if we were to solve this using the quadratic formula. Right? So it's not x equals negative 16. So don't put that there. If you want to put something here, it's delta. right? That'd be the best thing to put here. Delta is equal to negative 16. Because it's negative, it doesn't even matter what the number is for this problem. It would matter if we were actually solving it, but since all we wanted to know if it was going to be real or imaginary, all that matters is whether this is positive or negative. Because it's negative, the solutions are imaginary. So there will be 2 imaginary solutions. And so we pick B, non-real solutions means they're imaginary. So if this was positive 16, we would pick A, 2 real solutions. So if it's positive, you pick A. If it's negative, you pick B. When would it be 1 real solution? If it was 0. So if the delta is equal to 0, there's only 1 solution, and it's a real solution, but there's only 1. All right, so that's how you do number 8. All right, let's take a look at number 9. Okay, this is kind of a fun problem. So here, basically, we're working backwards. They're giving us the solutions to the equation, and they want us to determine what the equation should look like for those to be the solutions. I really like this kind of problem. I always tell a story in class I had this software for typing out mathematics. It's still around, but it's like really old. I don't know how well it still works on, the new operating systems, but it's called Scientific Notebook. And what was kind of neat about that is besides the fact that it made typing math a little bit easier than it was on Microsoft Word at the time. Now, that technology has come a long way, and maybe that's kind of why this software kind of went a different direction. Like, nobody really uses it. I shouldn't say nobody uses it. I probably should cut all this out from my video. But maybe people still do. It's based on what's called LaTeX, and that's definitely still used for writing scientific and mathematical papers for journals. It has very elegant, nice-looking layouts. The math looks really beautiful. The layouts for the papers look really nice. So Scientific Notebook used this, not technology, but used LaTeX for formatting the mathematics, but just made it easier, because doing it more directly was challenging, at least back in the day. Maybe that's easier now too. I don't know. Anyways, I'm really digressing a little bit too much here. The story I want to tell is that within that Scientific Notebook, one nice feature it had was you could design your own questions so that it would randomly generate numbers, and so that the problems will look different each time you open the document, right? Each instance of the document would have different numbers based on the parameters you put in for the different numbers that you wanted. So I was writing my own test, and I would say, okay, I want to write a quadratic equation. Let me randomly generate A, B, and C. The problem with that is if you randomly generate A, B, and C, so I'd say let A be a number between negative 10 and positive 10. Let B be a number between negative 10 and positive 10. Well, guess what happens? You'll get these equations with these random numbers that don't really work out the way you wanted, or especially if you want the problems to be a little bit easier, like the factoring version, of the problem of like what we just did, like this problem here, right? Let's say I wanted to generate a quadratic equation that worked out like this, where you could factor it to solve it. Right? If you randomly generate A, B, and C, it's not going to be that way very often. So then I would try to come up with parameters like, well, let A be 1, and then B should be based on A, right? So B would be randomly generated or calculated based on A, and C would be based on A and B. And then you do all this crazy math to try to make these numbers get randomly generated in a nice way so that you could factor it. And maybe I'm just a big dummy, but then I finally realized the easiest way to do the problem, to set this up, is to randomly generate the answers you want first. That way the answers are going to be exactly how you want them to be. So you would generate the answers here. So have these two numbers be any number between negative 10 and positive 10. And then from the answers, you build up to the problem. And so this is exactly what Math Excel is doing. This is what MyMathLab is doing. Any online homework system that randomly generates problems is doing it in this way. I'm sure of it, because it just makes the most sense. And again, maybe I just don't have a lot of common sense in it. I had to learn it for myself, but over probably a longer trial and experiment phase than it should have taken. But randomly generate the answers first, and then mathematically build the problem based on those answers. And that was a lot easier for creating my test. And so that's what we're going to be doing here. So what you're about to do for number 9 is what Math Excel does on all of these problems, which is start with the answers first and then build up to the problem. All right. So that all of that was to say that, and I'm sorry if I misspoke, or I didn't mean to malign Scientific Notebook. It's a great software package. I really enjoyed using it. Once my computer died and I got new computers, I never went back and bought another license for it. And I sometimes wonder if I should, because I really did like being able to design my own tests, but I haven't really looked into it in a while. I just let Math Excel do that for me now. So anyways, to take the answers and fit them back into a problem, we're going to want to do this process backwards here, right? So think about what happened here. Now, we don't want to get back to this crazy equation we started with over here, but just to this point right here, right? So to solve a quadratic equation, we factor it, set each factor equal to 0, and then solve for x. I want to do that in exactly the reverse order. I want to take the answers, set them back up as factors, and then multiply those factors out to get the quadratic expression, right? So notice that if 3 is going to be a solution, then x minus 3 would have to be a factor to give me that solution. If -1 is going to be a solution, we would get that kind of solution from a factor of x plus 1. And so the pattern there is whatever answer you want, x minus that answer has to be your factor. Right? So for example, if I want 4 to be one of my solutions, then the factor that would give me that solution would have to be x minus 4. That's what would lead me to an answer of x equals 4. If I want -10 to be a solution, then x minus that number would have to be a factor. X minus -10, or you could just skip to x plus 10, right? If I want -10 to be a solution, then x plus 10 would have to be a factor to give me that solution. And so these are the two factors I would need in order to get these two solutions. So there's your factors. And to make it an equation, you set it equal to 0. And then you multiply these together by foiling, right? So you're going to FOIL this out. So you do first, outer, inner, last, right? And so you'll get x times x, which is x squared. X times -4 is -4x. 10 times x is positive 10x. 10 times -4 is -40. It's still equal to 0. Combine these like terms together, you get x squared plus 6x minus 40 equals 0. And there you go. So now you have a problem that you can present to your students that you know will work out in a nice way, that it will factor and give you these nice answers because of how you constructed that problem. Right? And so this is exactly what Math Excel would do. So now when a student accesses your problem on Math Excel, they will see this. They won't know the behind the scenes that you started with the answers first in order to create that problem. They're just going to have the problem, and then they'll have to factor it. It'll work out like this, and then they set each factor equal to 0, and they will get the answers that you started out with. All right. Anyways, I'm sorry I spent so much time on that. Question number 10. So this is a quadratic-like expression or equation. So it's not really quadratic, because quadratic means the highest power is x squared, but it has the structure of a quadratic equation. So in order to, the proper way to do this would be to use substitution to transform it into a quadratic equation. And the key for that is to look at the middle term. So for a quadratic expression, you want it to look like this, which means you want the middle term to be a variable to the first power. You don't want it to be x squared. You would have rather it have been x to the first power. So I'm going to change that. I'm just going to cover it up with a new variable so that the new variable will just be to the first power. So it's like putting a mask over it. I'm just going to replace the x squared with a w. Now, you might say, wait, what about x? You said x to the first power, but I don't want to use x again. That's going to be confusing. I don't want to cover up x squared with another x. Then I'll forget which x is which. So pick a different letter than what's being used in the problem. But this w is now to the first power, so it matches up to this formula better. The number is fine. The -6 is not a problem. So we're going to have -6, but in place of the x squared, we now have a w. And then we'll have plus 9 equals 0. So that's how the rest of the equation looks. And that's looking a lot more like a quadratic expression. In order for it to complete that transformation, however, what I need to see here is w squared. Now, a lot of students will just assume that becomes a w squared. They'll just say, well, that's what I need it to be, so that's what it's going to be. But you really need to confirm that it becomes w squared based on your choice here. So you can't, you get to make one choice, right? I'm choosing to let w replace the x squared. Based on that choice, I have to make sure all of these consequences occur in order for this problem to work out. So x squared gets to be replaced with w, and that's all w can replace. W is only ever allowed to take the place of an x squared. I'm not allowed to do different things with w at this point. Once I've made my choice for w, I'm stuck. I'm locked in to that choice. So with x to the fourth power, for it to become w squared, we need to take a closer look at it. Does it actually transform into w squared? In order to see how this interacts with w, what I really need to find is an x squared, because once I have an x squared, w can take the place of that. So I can rewrite x to the fourth power as x squared to the second power. And once I have an x squared there, my same choice can be applied. W takes the place of that x squared. Right. So then so x squared gets replaced with w, and then that gets raised to the second power. So yes, x to the fourth power does become w squared. Now it's a quadratic equation. So I solve it just like before. I don't need to use the quadratic formula here because it factors. Two numbers that multiply to 9 add to -6 are going to be -3 and -3. So I get the same factor twice, which means I can just take that, since it's the same thing twice, I'm just going to do it one time. W minus 3, that factor, set it equal to 0, and then solve for w. And I get w is equal to 3. And a lot of students will stop there and say, okay, I solved the equation. But you're not done, because if you told Math Excel, for example, w is equal to 3, Math Excel is going to say, w? What are you talking about? What's w? Right? Math Excel didn't have a w. It doesn't know what that is. You could have made this any letter. It could have been Z. It could have been A, right? You made this letter up in order to solve the equation. But that's not what Math Excel is looking for. Math Excel is looking for x. So we need to, once we're done solving it, take the w back out. So again, think of it like a mask. If you pull this mask off, what's underneath the mask? Underneath the w is x squared. So you take the w back out, you put the x squared back in, and then you still need to finish solving this for x. And you do that by taking the square root of both sides, and you get x equals plus or minus the square root of 3. All right. And so that's what Math Excel wants to know. And that's what I would want to know on the test. All right. Number 11 works the same way. It's a quadratic-like expression. We will transform it into a quadratic expression by doing the same thing. Looking at the middle term first, I'm going to replace that x to the 1/3 power with a w. So this becomes -2w. The rest of the equation just stays the same. What I would like to see here is a w squared, but I need to make sure that's actually what I get based on this choice. So I'm going to rewrite this, x to the 2/3 power, by separating the 2 and the 1/3, right? So put those separately instead of having them in the same fraction. You can rewrite 2/3 as 2 times 1/3. And then I will put the x and the 1/3 in the parentheses. And then the power of 2 will stay outside the parentheses. And so again, once I see that x to the 1/3 power, the same choice can be applied, right? W takes the place of the x to the 1/3 power, and then that's going to get squared. So I end up getting w squared here. Now to solve this equation, I could use the quadratic formula, but it's going to be a lot easier if we just factor it, since it can be factored. Two numbers that multiply to -3 and add to -2. We've already done this one. It's -3 and +1. Still equal to 0. Set each factor equal to 0. You get w minus 3 equals 0. W plus 1 equals 0. And so what you end up with is w equals 3. And w equals -1. I just put some random mark in there for some reason. W equals -1. But again, we weren't trying to find w. W was something we introduced into the problem to make it easier to solve. But once we're done with it, we have to take w back out, go back to the original variable, which is x to the 1/3 power. Right, so take the w back out, go back to x to the 1/3 power, right? Again, if you think of w like a mask, you take the mask off, underneath it, what it was covering up was x to the 1/3 power, right? And so this also becomes x to the 1/3 power, right? So take both of these w's away, underneath both of them is the x to the 1/3 power. Now you can solve for x. Remember, a 1/3 power is just a cube root. What cancels out a cube root is a power of 3, right? So what you want to do with this is raise this to the, I keep picking bad colors here, raise this to the 3rd power. If I do that to the left-hand side, do the same thing to the right-hand side. The power of 3 cancels out that 3, that denominator of 3. So I just get x by itself. So x equals 27 for this case. Do the same thing here, raise both sides to the 3rd power. These cancel out. You get x equals -1 to the 3rd power, which is still just going to be -1. And so that is the solution set to number 11. Let's take a look at the next page. All right, looks like we're on to the graphing, and I'll try to go through this a little bit faster because this video is already at 55 minutes. So here we're going to be graphing quadratic functions. So what's different about these equations is that they have 2 variables. We have y equals, so remember, and we haven't seen this for this class, one drawback is that I don't know, I'm putting negative there, 2 times x minus 2 squared. Is that we introduced this notation way early in the course, like chapter 2, and then it just never has a place in the material that we cover until we reach this point in the semester. They use it a little bit in chapter 3, but there's no reason for f of x in chapter 4, chapter 5, or chapter 6. So it's been months since we've used this notation, but it's important for you to be familiar with it because it is used quite heavily in college algebra. So f of x really is just the y variable. It's just a fancy way of writing y. There's good reasons for having it, but don't worry don't let it bother you. Just replace the f of x with y and think of it that way. So it's quadratic on the right-hand side, but instead of being equal to 0, it's equal to y. So it becomes a 2-dimensional object here. And we're being asked to graph it. So there's going to be an infinite number of solutions. We want to find the graph of those solutions. And it turns out that for quadratic functions, the graph will be a parabola. So to graph a parabola, you want to find the vertex. And when it's written in this form, there's 2 ways of writing these quadratic functions. What we're seeing here is a quadratic function in this form. And this is called the vertex form. And the reason it's called the vertex form is because of how easily the vertex can be read off the equation. You don't even have to calculate the vertex here. You can just see it by looking at your equation. The vertex is at h comma k. Right? Here's h, here's k. Those 2 numbers are going to be your vertex. H is your x coordinate, k is your y coordinate. So if we compare this formula to this problem, we see that instead of h, we have a 2. Right? So h is equal to 2, and instead of k, we have nothing. It's a big empty space, which means k is equal to 0. And so our vertex is going to be located at 2, 0. So there's the vertex. The vertex will either be the very top or the very bottom of your parabola, depending on which way the parabola is going. If it's going like this, the vertex is the very bottom. If it's going like this, the vertex is the very top. Right? So let's see what we have here. So we have 2, 0, which would be this point right here. So there's our vertex. It's either the top or the bottom of our parabola. In addition, and it also asks us to do axis of symmetry. So that's a pretty easy thing to do once you have the vertex. The axis of symmetry is just the vertical line that passes through the vertex. I guess let me rewrite that. Okay. Right, so this will be the axis of symmetry, or the line of symmetry as they sometimes call it. I'm doing a really bad job of, I have the worst time drawing arrows, I feel like. I'm just really bad at it for some reason. That's supposed to be an arrow. Okay, so it's at x equals whatever the x coordinate of the vertex is. And that's just referring to the vertical line that passes through the vertex, which is this mostly vertical line I'm drawing over here. All right. Now, what you need to be aware of regarding this vertical line is that it's the parabola is symmetric to this vertical line. So for any point on one side of the vertical line, there has to be a mirror image point the same distance away on the other side of the vertical line. So what's nice about this is that every time I find a point on one side, I get a point for free on the other side. So in order to finish graphing this parabola, we need at least one more point. And then with the axis of symmetry, we'll get another point for free. And that would be the minimum that you need to do. So think of it like this. And I think if the vertex isn't too far away from the y-axis, probably the best thing for you to do is to find the y-intercept. And the way you do that is by setting x equal to 0. And it's just an easy number to work with. That's why it's a nice point to find. So I'm going to take x equals 0. I got to pick this. You can pick x to be whatever you want. You could try x equals 1, x equals 5. Just be careful that whatever you pick for x, it doesn't make numbers that are too big. But it's really your choice. I'm going to choose 0. And I'm going to plug 0 into the equation. So I get to pick this one, but then the equation has to tell me what the other one is. Right? So I'm picking 0 for x. I'll plug it into the equation. So we get f of 0 equals 2 times 0 minus 2 squared. I should use a different color there. And so that's going to be 2 times negative 2 squared, which will be 2 times 4, which is going to be 8. Right? Negative 2 squared becomes positive 4. And so y is equal to 8. So you see the numbers get pretty big pretty quickly. Right? So we get 0, 8, which is this point right here. That's 2 to the left of the axis of symmetry. So if I go 2 to the right at the same level, there's another point there. So I get that point for free. I don't have to calculate it. I just know from the symmetry that because this point exists here, there's a mirror image point the same distance away on the exact opposite side. And that's really enough. Probably a couple more points would help. But like I said, this video is already a little bit too long. So I'm going to go ahead and stop there. Now be careful, if you only have 3 points, don't do this. Oh geez, I can't even do the wrong thing here. Don't do this. Just be careful. Even that doesn't look so bad, but do not make it a triangle. Do not make it sharp line, and make it a V shape. It's not supposed to look like that. It is a smooth, rounded curve. So let me, I hit the wrong button. No, I hit the previous page button instead of the undo button. The problem with that is I can't undo that last mark, which stinks. I'm going to have to erase the whole thing. Oh, that really stinks. Okay. All right, let's mark these points again. What's another 20 minutes on this video, right? So, okay, so here's the points. Connect them using a rounded curve. I'll do the best I can. So it's going to look something like this. It's hard to do on this writing pad. Okay. All right. So even this kind of bugs me because I feel like, oh, I hit the wrong button again. I'm not going to fix it now because I hit the wrong button. Oh, man. Okay. So this kind of bugs me because this feels a little too straight. I hit the wrong button again. Gosh, okay. I'm going to redo it now. Since I did it, I made another stray mark. Okay. I'm sorry. Honestly, I'm feeling a little under the weather. Maybe my brain isn't functioning as well as it should. All right, so let's try it one more time. Oh gosh, okay, right. At least this time I hit the right button. Okay, not too bad. Okay. Oh geez, okay, now I can't. Oh, I almost hit the wrong button again. All right. Okay. I just can't see. You know what? Here, let me try this. Let me come at it. I just have trouble going to the left. I'm right-handed. Maybe that's part of the issue. Let me try to just go to the right instead if I seem to do better with that. Okay, so let's start up here. Oh, that's still not too good. Oh man. Okay. That's horrible. I can't let that go. I'm sorry. Oh man, you guys are gonna hate me. Okay. It's doing the same thing every time. This is really, oh gosh, this is even worse. Okay. So I'm using a bamboo tablet. I think it's bamboo, a Wacom tablet. And they have different models. Of course I didn't buy like the most expensive model. And it's like a blank, it's like writing on a table. Right. I guess that's the best I'm going to do. I guess what's bugging me is that I keep doing this little thing to the right. And it really shouldn't be like veering off like that. This part's not too bad. It's not the best, but let me try that instead. Okay, that didn't work out too good. Anyways, it's like writing on a table. It'd be like writing on paper without being able to see your writing. All right. And so that's the difficulty. So it's still veering off to the, geez, okay. I think I'm just going to have to leave it. Okay. It's going to look something like that. I can't seem to get away from that. anyways, it's difficult. The coordination required because you're seeing it on the screen, but you're not seeing it where you're actually writing on the tablet. And so I'm seeing it on my computer screen, but not on the table where I'm making the marks. And that makes it a little bit hard to draw. Not that I'm good at drawing anyways. Okay. Anyways, sorry about that. Again, y equals negative 12x squared. We're almost done. These should go a little bit faster. This one, if you compare it to the same formula, y equals a times x minus h squared plus k, it technically belongs to the same formula type, the vertex formula. The vertex is at h comma k, but this one, because it's so simplified, it makes it a little bit harder to see it. But there's no h. That number's missing. There's no number here with the x inside of this square. It's missing, so it's 0. And there's no k because there's no number being added or subtracted onto the end, so that is also 0. All right, there's an empty space here, so this will also be 0. So the vertex is at 0, 0. Right. And then we're going to plot some points. It doesn't say find axis of symmetry, but the axis of symmetry will be the y-axis. And again, it is kind of helpful to be aware of that. And so now we'll plot some points. I would say let's choose 0 for x, but we already have that point. We already had the vertex. Let me say that's not the vertex, but we already have the point where the x coordinate is 0. So I don't want to choose 0 again because I'm just going to get the same point again. So let's pick 1, again, to keep it easy. Plus, you really can't go with 2 because if you pick x equals 2, it's already too big of a number. Our window here is 20 to negative 20. If you pick 2 for x, you're going to get a much bigger number than that. I was thinking you'd get 24, but you're going to get negative 48, and there's just no room for it. So it's this graph, the numbers get really big really quickly. So really our only choices are 1 and negative 1. So if I plug in 1 for x, right, I'm going to get negative 12 times 1, which is going to be negative 12. And so I get the point 1 comma negative 12. I'm like dreading, and I'm sure you're probably dreading it too, how much time am I going to spend trying to draw this parabola? The symmetry tells me if I go the same distance away on the opposite side of the axis of symmetry, there's a mirror image point there. Again, the axis of symmetry would be the y-axis in this case. But you could also find out by plugging that into the equation here. Plug in negative 1 for x. You get y equals negative 12 times negative 1 squared. Be careful not to make this mistake. A lot of students will think, oh, negative times a negative is positive. That doesn't happen. You have to do order of operation, exponent first, right? Negative 1 squared is positive 1, and then multiply, and you get negative 12 times positive 1, which is, again, negative 12. Right? So you get the point that we already marked over here. And then you want to connect these again, not as a sharp triangular V shape or whatever, but as a rounded curve. As rounded as you can make this one, it's a very sharp curve, but it's not going to be exactly straight, right? It's not going to be like a corner with rigid lines. It's going to be rounded, but just it's still a very sharp rounding. I don't know if I'm saying that right, but so let me connect. Oh gosh, I'm just like, I almost feel like I should maybe let me pause the video so you don't have to listen to me like anguish through drawing this. I'll pause it until I have it the way I like it, and then I'll resume the video. So give me just 1 second. All right, so there's my graph. It looks like a octopus or a squid or something. But it's not perfect by any means, but I don't expect perfection on the test either. So, if that's what you give me on the test, I can live with that too, if you can live with it as well. So, all right, let's move on. We got a couple more problems to look at, and then we'll be done. I'm sorry for the length of this video. So then, again, this one is in vertex form. It's y equals a x minus h squared plus k. But this one has more numbers here, which kind of makes it a little bit easier, honestly. Remember, the vertex is at h comma k. And the thing with h, I don't know if you noticed it on the example that we did on the previous page. If we scroll back up, that h, even though there's a minus 2 in the equation, h is positive 2 in the vertex, right, for the vertex. Excuse me. h is what follows the minus sign, right? The formula has a minus sign built into it. It has to. That's just the way it has to be, constructed. H is the number that follows the minus sign, right? So here's the minus sign. The number following the minus sign is a 2. It's a positive 2. And so h is equal to 2. Now, if you apply that same logic here, it's a little bit harder to do because there's not a minus sign. It's a plus 1, but you could generate a minus sign there if you rewrote plus 1 as minus negative 1, right? So now there's a minus sign, right? Because minus a negative 1 is plus 1. There's a minus sign there, right? Just like we have in our formula. And I can't draw arrows very well either. H is what follows that minus sign, which in this case will be negative 1. Now, that's a lot of, work. I don't know if that's really work necessarily, but students don't usually like to bother thinking about it in that much, I don't want to say it. They don't usually like thinking about it to that depth. They just kind of want an easy answer. And so the easy answer here is it's just the opposite sign of that number. But you just got to be careful not to make it too easy. I mean, it's good to have an idea of what's going on here, why it should be the opposite sign of this number, thinking of it as the number after the minus sign. I mean, that's always good to have that knowledge because you're less likely to make a mistake with these problems. But the shortcut there is that h will just be the opposite sign of whatever this number is. If it's a plus 1, h is negative 1. If it's a minus 1, h is positive 1, right? The reason that's tricky for students is because k doesn't follow that same rule, right? There's a plus sign here. And so again, we have a minus 3, but that's like plus negative 3. So k will be negative 3. K keeps the sign of that number. So for h, it's the opposite sign. For k, it's the same sign. And that can be confusing for students, right? So it takes a little practice to get the hang of that. All right, and so the vertex is negative 1 comma negative 3, so that's what they were looking for here. The line of symmetry, we talked about that on a previous problem. It's just going to be x equals whatever the x coordinate of that vertex is. So once you have the vertex, the axis of symmetry is pretty straightforward. We'll get the minimum and maximum value after we graph. It will be from the vertex, but we don't know. I mean, we know, we can find out, but let's just graph it first. And then once we see the graph, it'll be pretty obvious whether it's a maximum or a minimum. So you have to make a choice. Is it a maximum? Is it a minimum? And so we have negative 1 comma negative 3. That'd be right here. That's our vertex. We'll plot 1 point. We'll, do the work. We'll plot 2 points. We're going to do the work for 1 point and then use the symmetry to help us find a second point for free. And like I said, if you don't already have that point, a good point to find is the y-intercept, which is where x is equal to 0. We don't already have that here, so we'll go ahead and find that now. So I'm going to plug in 0 for x. So I have f of 0 equals negative 0 plus 1 squared minus 3. Let's try that again. Minus 3. And so we're going to get negative 1 squared minus 3. It's going to be negative 1 minus 3, which is negative 4. Now be careful, again, order of operation. You do the exponent first. 1 squared is going to be 1, and then the minus sign just copies down. So it comes out negative 1 still. All right, and so we get 0 comma negative 4, which is going to be this point here. So now we see this parabola is actually going to be heading down, right? The vertex is either the top or the bottom. If this point goes below it, it can't be the bottom anymore, so it has to be the top, right? The symmetry is this vertical line right here through the vertex. This is 1 to the right of that line of symmetry. So if I go 1 to the left, I should find a mirror image point located there. So these are all kind of clustered close together, which should make this part a little bit easier for me to do. So now, I maybe shouldn't jinx myself like that. Connect these points as a parabola, right? It's going to look something like this. And I'm just going to keep it short and simple. All right, so there's our parabola. So is this a maximum or a minimum? Well, this point is at the very top of the graph, which makes this a maximum. There's no minimum because this graph keeps going down forever. So there is no minimum because there's no bottom to it. It just goes down forever. All right, but there is a maximum. It doesn't go any higher than this point right here. So it's a maximum, and the maximum value of the function, which means what's the maximum y value? It's like asking about the range, right? What's the highest y value you can get? It's negative 3. The y coordinates do not go past negative 3. All right, and so the maximum value there is negative 3. All right. Look at this problem. Same thing, except we're going to have to do a little bit more work to find the vertex. All right. So the vertex in this case, we can't read off the equation. I wish we could. It's not going to be at 4 comma negative 7 because it doesn't fit that formula. This fits the other formula for a quadratic function called the standard form. And it's the one that we were kind of referring to earlier when we were doing quadratic equations, right? ax squared plus bx plus c. To find the vertex from this form, we actually are going to have to do a little bit of work. There's a formula for it. It's a very simple formula. The x-coordinate is negative b over 2a. If that looks familiar, it should because it's part of the quadratic formula. It's the leading part, right? So if you think of the quadratic formula, negative b plus or minus the square root b squared minus 4ac over 2a. This is it right here. Negative b over 2a is built into the quadratic formula. This is the value that is exactly halfway in between the two x-intercepts. And that's exactly where you would expect to find the vertex because of symmetry. So that's why this is the formula for the vertex. All right. Now, so in this case, b is negative 4 and a is equal to 1. All right, so there's b, there's a. Plug that into this formula, so we have negative sign in the formula. B is negative 4 over 2 times a, which is 1. And so double negative cancels out, and so we'll get positive 4 over 2, which is going to be 2. All right, so that's the x-coordinate of the vertex. But in order to have the complete answer for the vertex, we also need the y-coordinate. And so let's go ahead and plug. So I'm giving away the answer I was about to ask, which is how do you find the y-coordinate once you have the x-coordinate? You plug the x-coordinate into the equation, right? So now that I know x is equal to 2, plug that into the equation to find the y value, right? So we'll have f of 2 equals 2 squared minus 4 times 2. Sorry, kind of glitched on me there. 4 times 2 minus 7. So we get 4 minus 8 minus 7, which is going to be negative 11. All right, and so the y-coordinate's negative 11. So the vertex is at 2 comma negative 11. So there's the vertex, 2 comma negative 11, which is a little ways down here. All right, the line of symmetry, again, once you have the vertex, that's easy. It's just going to be x equals 2. It's whatever the x-coordinate is for the vertex. X equals that number is your line of symmetry. It's this vertical line here passing through the vertex. To complete the graph, we need to plot at least one more point, and then we'll use the symmetry to get another point for free. I'm going to choose 0 again since it's close by. Now, if my vertex was like way over here, you don't want to choose x equals 0 because it's too far away. The number is going to get too big, and you won't be able to graph it. But as long as it's close by, 0 is a good choice. So we'll plug that in to our function. So we're going to have f of 0 equals 0 squared minus 4 times 0 minus 7. So while the standard form makes finding the vertex more challenging, it makes finding the y-intercept a lot easier because when you plug in 0 for x, those terms just go away and you just get negative 7. So in fact, what you can learn from this is that when it's in standard form, the y-intercept is just c, whatever that last number is. That's the y-intercept. So it's going to be 0 comma negative 7, which is heading up this way. The symmetry, that's 2 to the left of the axis of symmetry. So if I go 2 to the right, I get another point there for free. And now I can draw my graph. Okay, I just got to hold my breath. Maybe that was the mistake I was making earlier, is I was talking and breathing. So if I stop talking, stop breathing, I can draw a little bit better. Okay, this time the vertex is a minimum. It bottoms out here. There is no maximum because the graph goes up forever. So it's a minimum, and that minimum value, the lowest y value that you can get is negative 11, right? It's whatever that value is from the vertex. That's going to be your minimum value in this case. All right, so last page. For the last review video of the course, at least for chapter reviews anyways. And it's really the same problem that we just did. I'm trying to think, is there anything really different about this? how about, to shorten the length of the video, I'm going to pause my recording. I'm just going to work this out. Why don't you go ahead and pause as well and see if you can also work it out. And then when you resume the video, the answer is just going to be on the screen. I'm not going to sit there and make you watch me go through the steps because it's going to be the same steps as number 15. All right, so go ahead and pause the video. I'm going to do the same thing and then we'll resume. All right, so here are the answers to all the parts of this question. The vertex is 3, 11. The line of symmetry will be x equals 3. To find another point to graph, you plug in 0 for x, and you see there's no work here because I used the shortcut that the y-intercept is just going to be this number here, the value for c, which is 2, positive 2. So it's going to be 0, 2. Symmetry gives me this other point that this is 3 to the left, so I go 3 to the right to get that other point. And I actually drew this on my first attempt, so maybe I'm better at drawing these upside down than I am right side up. And that is a maximum because the vertex is at the top of the graph, so it's a maximum. The highest value there is going to be 11. All right, and then to find the vertex, x is equal to 3. Use the same formula, negative b over 2a. You plug in 6 for b, negative 1 for a. Comes out positive 3 when you do that. And you plug it in here to get 11. So you can pause the video and take longer to think about that if you need to. I'm going to go ahead and move on to number 17, the last problem of the test. And this one, we don't have to graph, thankfully. It's just about finding x and y intercepts. And we've already done, let's go ahead and do the y-intercept because we can use our same shortcut. It's in the standard form. The y-intercept is just going to be 0, 8. Maybe I need to back up for a second there. So to find the y-intercept, you set x equal to 0, just like we were doing on the previous problems. And then you solve for y, right? So step 1, set x equal to 0. Step 2, solve for y. And so we get negative 0 squared plus 2 times 0 plus 8. But just like we saw happen on the previous problems, those terms go away and you just get 8. So you get 0, 8. That's the y-intercept. So that would go here. For the x-intercept, it's going to be a little bit more work, but it's the same idea. It's where the graph crosses the x-axis. And where it crosses the x-axis is at y equals 0. So you set y equal to 0. Well, remember, f of x is the y variable. So I'm setting that equal to 0. So I'll get 0 equals negative x squared plus 2x plus 8. And then I want to solve for x to get my x-intercepts. Well, this is a quadratic equation, so it's going to be a little bit more work to get that information. This is factorable. You could use the quadratic formula. Let's just start off with that. You could use the quadratic formula if you want, but I think that's more work than it needs to be. This is factorable, but as I mentioned earlier, it's just more difficult to work with these expressions when a is a negative number, especially if it's negative 1. So what I'm going to do is factor out that negative sign first. Of course, that changes the sign of these terms as well, but at least now a is positive, and that's going to make this a lot easier to factor. Now this is a 1, this is a 1. Find two numbers that multiply to c and add to b. Multiply to negative 8 and add to 2. Negative 2. That's going to be negative 4 and positive 2, right? That multiplies to negative 8, that adds to negative 2. So that's how that will factor. Now you set each factor equal to 0 to solve, so you get x minus 4 equals 0, x plus 2 equals 0, and then you solve for x in each case. So you add 4 to both sides here, get x is equal to 4, and you subtract 2 from both sides here, and you get x is equal to negative 2. You might say, what about this negative sign? It doesn't do anything. It doesn't do anything for finding the x-intercepts. Now, it's important for the equation, like if you're graphing it, that negative sign is very important. It determines the behavior of the parabola pretty significantly. But for finding the x-intercepts, it would be the same whether that negative was there or not, right? If these are your two factors, this negative sign doesn't change the answers you're going to get. So so that's, I don't know, maybe I said that wrong, because here it made a difference because we had to factor out the negative. But once it's a factor, it doesn't contribute anything when you're finding the x-intercepts. But if you were going to do other things with the equation, like if you're going to set this back equal to y and find some more points, that negative sign is important. So you can't ignore it in other cases, but you can ignore it when you're finding the x-intercept. So gotta be careful what I say. So now when you go to write the x-intercepts, you don't pair these two numbers together. It's not 4 comma negative 2. each of these pairs with 0 for y. So this is going to be 4, 0, and -2, 0. Those will be my two x-intercepts, and that's how you need to write that on your paper or type it into Math Excel. So I'm going to go ahead and stop there. This video went on way too long. I apologize for that. Good luck on your Chapter 7 test. If you're one of my students, please contact me if you have any questions or concerns. Thank you for watching.